Good afternoon, students. In this session, we will see the topics which are evolving in this programming of the cloud and software environment. In previous session, we have been discussed about what are the features of a cloud and what are the platforms we are using for the cloud environment. Means what are the traditional features we are using and what are the data features it is mentioning and how it is going to support. Means what are the platforms we are using. Means uh, runtime at the runtime or at the programming environment. What the features we are evolving in this one has been discussed in the previous session. Before going to this one, I will give a quick review about all these features what we have discussed earlier. So if we see what are the traditional features, means we have seen the what is the workflow and how we are going to describe these data transports and what are the infrastructure cloud features what we are using for. Apart from this, we have seen also the data based features like how we are storing the data, means using blobs or the distributed file system or any algorithms or any type of the representations what we are supporting for that one. For this type of environment, means for this runtime support or the parallel type of the environment, we are using some programming models here. Apart from also means uh, we also representing these programming models in these parallel and distributed programming paradigms also. And what are these considered are there are the map reduce and Hadoop representation is also there. DAG representations also used. In the map reduce only, we are specifying iterate to map reduce representations for processing the data, and we are also using the twister for uh, modeling or for processing our data by using simultaneous means parallel execution and also the distributed execution. So in previous session, there is a just a introduction of the things what we are using in these uh, cloud programming and also the environment what it is supported, the software environment what it is supporting. So in this representation, we are using a parallel and distributed environment here. Why we are using this parallel and distributed environment means first we should know or first we will know what is the paradigms what we are supporting and what makes the usage of these parallel and distributed environment together. Means we are using parallel computing and we are also using the distributed computing. But what makes or what are the motivations or what are the things causing to use these things to be specified or to be run on a parallel way using the distributed manner. So these are the things we have been seeing in this session. So here, before getting into this one, first we will see what is the distributed environment and what is the parallel environment. If we see what is the terms what we are representing in this environment or the distributed computing and then parallel computing. So what is these distributed computing system or what are these terms are representing here is that we can specify them as a set of computational engines which are connected by a network. What they are connected or why we are using this type of representation here is we need to take these computational sets which are connected has to achieve a common goal only. Means they have to run on a job or it is a single job or they have to run on an application only. Means they have to run only or they have to work on the single application only. Likewise, we are having a example here is we can take a computer cluster or you can specify a networking environment. You may take or we may consider LAN, MAN, WAN or any type of representations for processing because we are using set of the computers to be connected to a server, or you can specify you can it to a router or it to a bridge or it to a switch. What it is doing, it is allowing these computers to enact to work on a that is a scheduled one or a specified one only. So if you go for the another type of the representations where the workstations can be specified also. These type of the environment what we are using can be treated as a distributed computing system. Why? Because we are using distributed means we need to take these. There is a notion, you know that there is a divide and conquer is there. Why we are using the divide and conquer method or any that is a, what is a methodology it is specifying here. Before getting into the another type of the representations or before getting into a solution, what you have to do is nothing but first we need to take the problem. The problem has to be specified and we need to divide into the small problems. So like that, yes. Likewise, if you want to work on an application or any type of the representation, what we need to do? We need to take or we need to specify the work has to be partitioned from that has to be given to the many people there. You may take the many people can be more than two or three, or you may take only two people, or you may take hundreds of the people. So based upon the application or the based upon the job what you are means getting on into that one, then we will decide how many people or the how many systems to be used for this processing. So likewise, any computer or the any clusters, networking, all these things has to be specified in the an example of the distributed computing system. And coming to the next representation, that is the fundamental term what we are using here in this programming paradigm is parallel computing. So here, what we are doing is this is also executing these things in a simultaneous way only. But here there is a slight difference. What we are using to represent the parallel computing here is we can use more than one computational engine because these engines cannot be can be connected to a network, or you can specify that they has to be connected to a network. There is no such condition there. So any type of the representations or the any parallel processing can be caused or they can be gathered here. How we are going to, how we are executing these type of the things here is we need to consider how we are going to process here. We need to consider a set of computers or the set of systems here. How we are going to process these things to be done here. We are not taking these systems to be connected into an environment that is into a network, or we may consider that it has to be connected to this representation things in this environment only. So what they are doing, parallel computing or the parallel representations of it. So what it is specifying here is to execute or to process any application or any job. There is no need to be connected to a network or a single network, or you may specify to its own network only. So to execute your program or to process your program or to process your application, what we need to do, we need to connect to or we need to execute this one. There is no such representation that you should use you should specify that they have to be connected to this network only. Okay, that is the parallel computing. That means they are simultaneously executing. This simultaneous behavior won't be from the environment what we are using, or they won't be from the thing what we are representing here. So here, what type of the environment or the whatever thing it is supporting here is that it is not supporting a distributed computing or the distributed environment. So here it is supporting non-distributed computing, or sometimes it may use the distributed also. So that's why what it is doing, it may use either a distributed environment, means there has been connected to a network, or they have been formed a cluster, or they have been under a some server, like that you will specify. So likewise, what we have to do, you need to specify what type of the computation has to be used for your process. So likewise, we will decide for parallel computing. You can use a distributed computing, or also you can use a non-distributed computing also. So here, that type of the platform what you are mentioning here is a multiprocessor platform. So here in this representation, the two fundamental terms what we are representing here is a distributed computing and parallel computing. What is the distributed computing here is specifying here is we need to consider a job has to be done across taking a network, or you can specify a workstation or a cluster. So what they have to do, they need to be connected to a environment here, means that is a remote, or cannot be connected from anywhere like that. So they should be in a network to connect to that one, and they are processing like. So whereas coming to the parallel computing, there is no such notation is there. If you want to connect to that, like you want to compute any type of representation, what you have to do, you need to be able to process. That's all. So the processing environment will belong to your network or may not belong to your network. That is not up to the computation here. So what is the thing is, you need to process your thing, that is the job, then you will process the job, and then you will give the output, or you will give the thing what you are choosing here. So likewise, what he has to do, we need to specify these parallel computing and distributed computing in such a way. So here in modern world, or nowadays, what here is, we are running a parallel program, means we are running a parallel program which has been used in this parallel computing on a distributed computing system here. Means we are using these parallel and distributed environment at once. So how we are processing, how we are getting this, why we are choosing this type of paradigm or this type of the thing is, it is making available of it is making allow take the advantages here, several advantages are. So for whom means why we are choosing this one is, we are having some advantages here. Who are getting these benefits? These benefits are being for the users, and also the systems what you are using. So the distributed computing systems what you are using also will take the advantage also. So here, from how we are elaborating this thing here is, if you go for these users perspective or the users thinking, so it will decrease. It will decrease the application response time. Means it won't take any longer time, or there is no waiting time. So here there is no such long waiting time will be there. So what it is doing is, it is taking these responses to be done in a fraction of seconds, or the milliseconds, or nanoseconds, like that it is specified. If we consider the distributed computing system point of view, or the perspective, what it is doing is, it is increasing its throughput and resource utilization. So throughput means overall thing. Overall means from the long stand of time, or the long period of the time, how it is going to execute, means how far it is executing, what is the performance of execution, has to be considered here. And also, what are the resources we are being means availed for these application development, or for executing these jobs, has been utilized in such a way that, so there is no any pending, or there is no any resource has been left for idle or like. So here, by using this type of the environment, we will get these benefits. How far we will get these benefits means, we are getting in the user's point of view, or also we are getting these things advantages in the that is system point of view also. After all, if we are choosing this type of the programming also, we have the some that is hurdles also. So what are the hurdles we are taking here is, there is a complexity has to be specified. So what is it is, running these parallel program on the distributed computing system is a simple not one. So what it is a very complicated process here. Means we need to take care of the data flowing, or we need to take care of the control flowing. What are the programming methodologies or anything, any representations what we are using for type of these parallel programming has to be looked, means how we means it has to be continuously monitored here. Means it is, if you are executing a single job, then that will be very easy here. What we are doing, we are executing the parallel environment here. So in this parallel environment, what you have to do is nothing but we have to look after the data flow here. So the data flow of these running these parallel applications on distributed systems is we can say that is a little bit complicated process. So here, to overcome this complicated process, we need to design or we need to look after the each and everything what it has been occurring or it has been causing or opposing this type of the processing's advantage. So, so what are the advantages here? We can see is the, that is the response time what you are taking is the, it can be specified as the less one. So here, and it is increasing the throughput and also increasing the resource utilization also. As coming to the disadvantage, not all the disadvantage thing what we are representing means the application which has been running parallelly on the distributed computing system has to be means implemented on the system. So the implementation process what we are representing is a complicated one. So the that is about the some representations what we are using, fundamental terms what we are using, why we need to consider the things what we are proceeding. So before going to this representations, we have seen means what is the parallel computing or also what's the distributed computing, why we need to use the parallel computing into the distributed environment here. So while processing this type of the environment means when we are considering the distributed systems here, so the distributed system will consist of some set of the nodes or the that is the network nodes or the, some you can say network workers or the things stations like this. We need to specify here while dealing with the distributed computing system. So if we go for this type of the environment, the system issues will be there. So what are the system issues will be specified when we are running a typical parallel program either in this parallel environment or in a distributed environment here. So that is represented in these steps here, means these are the issues, means partitioning, computational partitioning, data partitioning, mapping, synchronization, communication, and scheduling. So these are the issues we are getting here. So coming to the partitioning, so here we are partitioning these things, means things into the multiple ways. So that is the computation partitioning and data partitioning here. So what is the partitioning here is we are splitting up the job here. Partitioning means we are splitting up the job. So here when we are dealing with the splitting up of the job, then we are having some issue with that one. So while coming to the splitting up of that one, that is partitioning, we are having multiple things has to be considered when we are dealing with this. So the first one is the computation partition. So here what it is doing here is it splits a given job, or you can say specify a program also into smaller tasks here. Means it will divide a program into a sub programs, or it will divide these a task into the subtasks. So here when we are getting into these things, what you have to do is nothing but we should know what the task what we are dividing, and also we need to take these task things, means if we are dividing the task, we need to give all the things to the task, that is there is any shared thing is there, or you are allowing that is data variables or there, or any type of the representations which are supporting for this task has to be take care of this computation partitioning. So here this type of the partitioning what you are using will depends upon the portions of the job what you have been executing concurrently. Simply dividing is not the thing. What you have to do, we need to take which task has to be divided. Simply dividing one program into the subprograms is not allowed here. What you have to do here, we need to specify that. We need to take care of that. So which part has to be processed here, which part has not to be processed, like that it means which is a subprogram or which is a subtask. And then next, what is a subtask, other, like that. What you have to do, we need to identify all these. So in other words, like that, how you have to do is nothing but we need to get into the parallel execution here. Means there is no, that is, we can specify that there is no things has to be stopping this type of execution here. Means if you are dividing a program into that one, so what it is, individual executions has to be specified. Means there is no any other executions will affect this subprogram, like that. What you have to do is nothing but parallel executions has to be done. Parallelism, we need to identify the parallelism. For that, what you have to do is nothing but we need to divide these things into the parts. So if this part has been specified, what you have to do is nothing but we need to take care of the data element, what it is. So here we need to share, or we need to take the copy of the data for execution. Means when we are dealing with execution, we must use the data element. So the data element usage means, so if we are using a set of the data elements, they will be updated. The updation of the program, these elements will not affect any of these. Means we are supporting the parallel environment here. The parallel environment means we need to consider the representations. In the previous sessions also we have seen these parallelism. So how we are going to execute the inspection parallelism is. So how we are going to execute the inspection parallelism with one. So there you need to choose the instructions which are being the processing in such a way that there is no effect on the instructions, updations, or like that we need to consider. So likewise we need to specify the data elements here. We need, if possible, we need to maintain the copy of the that is data also, or you can provide the shared environment for process. So likewise, we need to take the data partitioning into an account. So here, likewise, we are seeing programming into the, means before processing, we what we have done, we need to identify what are the programs or what are the jobs here, that is identifying, parallelly executing. Likewise, we need to consider the data also. So here, what we are doing here is, we are splitting up the inputs here, or we can specify the intermediate data elements also will be used here. So here, we can specify input or the intermediate data elements what we are choosing into the smaller pieces. So here, what you have to do, we need to identify, likewise, the computation partitioning, we need to identify what are the input data elements which are parallelly used in this execution. So while executing these computations, that is, there is a job or the task, we use the data elements here. So we need to provide the data elements while executing only. So that is what it is doing. It needs to consider these things to be divided in such a way that we need to identify what are the parallel elements what we are using for process. So here, likewise, what we are doing, we are maintaining the copy of the same data here. Or likewise, we are taking here is we are maintaining the copy of the same program here. So the data elements should know about the programs. The programs should know about the data elements. So the data part what we are using. So they need to maintain, or they need to take the a copy of the things to be specified here. And coming to the next one, mapping. So here, what it is doing is, so we identified smaller portions of the task and also the data elements here. What we need to do here is, we need to assign these smaller parts of the program or the smaller parts of the data to their resources. So for this time, for this thing, we are using the mapping. Means we identified our programs, that is tasks, and we identified the data elements which we are using around these tasks while executing parallelly. So here, to execute, we need to assign or we need to process these things. That is the programs, either programs or the data has to be given to these underlying resources here. So this type of the process has to take these assigning of these parts or these data elements or the task to be uh, assigned to the that is described or the prescribed only. Means we need to take the simultaneous executions also, and we need to give these uh, any type of the executions to be done if that is in a distributed way also. So first we need to partition, and next we need to take the mapping. Partitioning means we need to partition the program and we need to partition the data. So after the partitioning, what we will do, we need to map to the that is prescribed, that is destination there. So after that, we need to take the next issue into an account, that is the synchronization. So here, what we are choosing here is the parallel environment. Means we are choosing parallel environment, means parallel users or the parallel workers we can specify. So here we are taking different workers or the different users to perform the different tasks here. So we need to maintain a coordination among these workers and also the synchronization of the process what they are being processing. So here, to maintain this synchronization and coordination, what we need to do here is we need to take a necessary thing to be specified here, that is the race condition. So here what we are doing is we are taking that is accessing points, and also we are providing that data dependencies there, and also we are providing data abstractions like that. Many things will be chosen here, because when multiple users are trying to access the or trying to execute the task, they will try to access the data also. So we need to identify or we need to specify that whether these workers or the users are being properly using these things or not. Means we need to monitor all these things. For monitoring, we are keeping that how far they will access. Means if you want to execute your program, how many times you will access the memory spaces, that is the shared memory or the what the memory processing what you are using. Means how many times you can specify, that is the shared resources, how many times you can access. So you can take the counter or the into an account there. So when you are taking these things, so my if I am going to execute a program, what I have to do, I have to use this memory accessing will be 2 times. So if I am trying to access the third time, it won't allow to process, because the counter, the value has been set to the 2. Means I am exceeding my usage. Means how I am exceeding the usage means whether that may be correct one or that may be not the correct one. So if I am the third person, what it is doing, it is taking some representations to allow me. So if I am not the third person, I am an intruder. I am an intruder. What it is doing is it won't allow me to access the data here. Why? Because means the accessing of that one shared memory has been limited here. So you can access the resources or you can access that one to the multiple access will be there. So the multiple access has to be restricted there. Multiple access has to be restricted. Means if you are not being restricted, what it is doing is continuously some person is accessing the other data, because it is being shared among the others also. So here we need to identify whether this worker has the need of accessing the data or not. Means we need to identify before the things has been processed here. Means we should know what the worker is doing, that is what the user is doing, how far he will access the data or how far he will access the things what it has been assigned to that that is application process. So if he is not able to access that one, means if he is not supposed to access that one, that is the thing. So by that you will come to know that that is the person who is, that is the worker or the user is not, he is means accessing the that is not the unauthorized one, or is not accessing the authorized or unauthorized resources, like that you can, yeah, you will come to know. And also we need to consider these shared data will be there. So we need to continuously update that. So any updations which has been done by the any other task to that data element need to be updated in this shared space, because some other people will be using, or the will be awaited for this thing to be used for their process. All these things has to be updated, or the processing. There is a coordination and the synchronization has to be maintained while processing, or the while executing in a parallel way. And coming to the communication, so here we need to specify the uh, data processing, or the data means sending will be there. Means sometimes some tasks, some owners, sorry, some users will wait for the data processing select. So how they are going to access this data element, for the how they are into processing, they will have the one type of representation that they will use the message passing interprocess, like that they are using the message passing technique to communicate with that user. And what it is doing, it is they are in requesting for the data elements, that is you can send me this data, or they like that you will request for that one. So they will allow you to access that. So here we are allowing the things to the communication has to be maintained, or the communication has to be established between the workers here, that is users. Means always the admins, or the always the main person will look after all these things. It's not the person, because many workers or the users will be there. One person will won't be able to look after the things what here. So likewise, what you have to do, we need to consider the communication mechanisms between the users here. If it is means reliable, or if it is the means there is no any problem while processing, or while means interacting with each other, while sharing the data of that one. So then it will be easy to access this type of the communication mechanism. If you are raising any, means if you are having any problem to connect, or if you are having the data dependency errors or any like that, what you have to do is nothing but we need to specify the triggering way, or the we need to specify the sending of these data elements to the users for here. Coming the last one, scheduling. So here, if you consider a job or a complete program here, what we need to do here is we need to identify the number of the computation tasks here. Means in the first step we have been means there is a partitioning has been occurred among these programs and the data elements what we are using. So here we need to identify, when we want to identify, so the number of the computation parts, and then the number of the data parts what we are choosing. So here first we need to identify, and we need to take these available users also. So here you need to make up the matchup here. What for example, we are having the 10 users or the 10 workers with us. If we are having only 5 computational parts only, then there is no use of the remaining 5 people here. So we need to consider, we need to execute these things on the 5 computing systems only. The remaining 5 people will be idle. So like for that only, first we need to take the program. So we need to identify the computation parts and also the any data parts also. So what we have to do is nothing but we need to take the count here. So if it is been greater than, if the computation part count is more than the number of the available work, what it has to do is nothing but we need to take the scheduler here. So if it is means the computation parts count is less than the workers term, then there is no any problem. There is no need to schedule this one. So if it is means greater than that, if it is more than the available workers here, we need to take a scheduler into an account. So what this scheduler will do? means he will select a sequence of the test, that is task or the any data pieces what you are considering. So what it is doing, he will be selecting the randomly, and it is being assigned to the workers. So apart from this, it also allows to, means the scheduler will allow you to take the resource allocators to be into an account, because it's simply executing, it's not the thing. What it has to do, it needs to take the resources to be executed. So for this resources, what it is, for this allocation, we need to consider the mapping into an account. So here, this one. So it is the resource allocate what you are using has to be taking the actual mapping into an account of these computations or the data pieces to the assigned workers only. Okay. After that, what we are using, we are taking unassigned tasks into an account. So first we should know whether these assigned or the unassigned will have the effect on. So likewise, we need to decide which task has to be allotted or the allocated to the workers first, and which has to be make it as a unassigned, has to be known by the scheduler here. So likewise, we need to consider a computation mapping here. So whenever we are taking these mapping has to be done, then the scheduler will take these unassigned tasks into an account, and also taking these scheduling policy into an account. Means if it is, means if you are taking any type of the representations like they are not running simultaneously, or they are not being used in a parallel environment, there is no usage of the scheduler. What we are using the simultaneous environment here. So when we are using the simultaneous environment, then only you will have the scheduler into your account. What is the condition here is, whenever the number of the computation parts what you are using or the data pieces what you are using, the count is more than the available workers, then only you will have to schedule. Scheduling means then there is no efficient, effective systems, or there is no the systems, means the count minimum systems what you are processing here is not being equalized with the amount of your that is the count of your computational parts. So what we need to consider here, we need to consider uh, scheduler. We need to take the task to be assigned to the workers, and then unassigned will has to be given to these workers later, like that. So these are the issues what we are being seen. That is the system issues what we have been considering when we are running a parallel program, or the means simultaneously executing program in a parallel environment, or you can consider a distributed environment also. So after that, we will have the motivations. The motivation for using these parallel computing or the parallel and distributed programming paradigms here. So here the thing is, it is completely for the data flowing, means for handling the data flow. Means if you consider parallel and the distributed programming here, so that handling of these data flows is a difficult one, and also we can specify that that is a very time consuming process. So why it is using why it is specifying that very time consuming means, to process or to handle this data flow, we require some specialized kind of that is a knowledge of programming models here. And also we have been seeing some issues of the, that is partitioning, mapping, synchronization, communication, scheduling, like. So we are having such issues. So this type of the issues means, these issues may or may not affect the productivity of your that is the programmer, and also it may result in the affecting factor of the program's time, and also that is delivery time what you are using, that is end program application development time has been crossing when we are choosing that. If we are uh, representing this type of that one, that is data flowing has to be handled, we need to consider some models. Means we need to design. We need to design some models which will support these parallel and distributed environment together. So this parallel and distributed programming paradigms, or you can specify these models, has been used in many years. So here we can use them in that is in Google Map Reduce and also Hadoop, Dryad, Twister, and several representations are there. So in these representations or these models, what you have to do is that they will provide the users which an abstraction layer. What it is doing is it has been using to hide the details of the data flow. Means there is no need to consider these they write codes or anything has been not been represented here. And also we need to specify that we need to take these parallel programs into an account. So why we need to consider the parallel programs means the work what is which has been done by a single person, or these things will be done by the multiple persons in means in a less amount of the time here. There is a time has been when we are dealing with the time or any that is power, all these means the consuming will be very less when we are dealing with this type of the representations. And also we are having other also we are having other type of the representations when we are dealing with the motivations here is we need to consider the productivity of the programmers into an account, and also we need to specify the programs to be the programs execution time what you have to specify has to be considered, and also the usage of these uh, resources has to be in a more effective way. Means the resources what we are designed, what we are processed for using or for being specifying for this representations for application development has to be availed in more effectively or efficiently. And coming to the system point of view, throughput has to be considered here. We need to consider the increase in the throughput here. These are the paradigms also, and also we need to consider another motivations also. And coming to the another type of the representation, we need to support these higher levels of abstractions when we are. So when we are dealing with this type of the presentations here, what could be the motivation means? So here we need to take the time into an account or throughput into an account, or you may consider the resources availing and also consider and also considering that number of the process where we are including that is the application has been developed in such a way that we need to be means put into the market very fastly, and they has to be include many features they. So all these things has to be considered while dealing with a application development. So when we are executing or when we are developing an application here, we need to consider that the time is an important factor. That is when we are dealing when we are accessing or when we are executing all these. So likewise, when we are executing in parallel and distributed programming environment also, we need to take these things into an account also. So here it is dealing with these computations on the data elements. That's why we are using some abstractions into an account. So here, apart from these, that is time, throughput, and the resources availing, we need to take these abstraction into an account here, because we need to hide the details of these data flow from these things what we are using here. So likewise, we are taking many things into an account for supporting these programming models, likewise MapReduce. So here in this MapReduce, what we are doing is we means the previous session also we have seen an example in previous classes. We have seen MapReduce examples also, and also we have gone through some presentations what we are using, why we are considering the MapReduce into an account, because it is supporting the parallel and distributed environment. In if you consider the large data sets also. So if we are taking this type of the environment, what it is taking, it is abstracting the data flow it is running on the parallel programming environment, which is being used on the distributed computer. So here, what it is doing is it is allowing to take the accessibility of these parallel environment by hiding of all these things. It is the data. So how it is going to take to be happen here is the we need to take these things to be done in a programming way. Means we need to take these the functions or we need to specify some definitions to that one. We need to consider the logical data flow into representations, and also we need to take the data flow into an account, and we need to specify several strategies here to solve these problems here. Because when we are dealing with this type of the representations parallel environment, the partitioning will come into an account. So when we are dealing with the partitioning in any representation, in any type of the representations or any type of the application oriented one, when we are dealing with the partitioning or the parallel environment, so what it has to do is nothing but we need to look after the computation and also the data partitioning. So here we need to take computational partitioning and the data partitioning, and then next mapping into an account. And also we need to consider the workers which are being used for processing here. So when we are dealing with type of the things, then it will come into the scheduler's point of. So the scheduler will look after this. What the assign it, what the task has to be assigned, what are not to be assigned, so that how will be being executed. Likewise, we need to take these things into an account when we are processing or when we are means dealing with the parallel environment. And we also use many these clusterings also has been specified in using these MapReduce or the Twister or the Hadoop or the Dryad also Hadoop library from these Apache. All these things are being used in such parallel under that is distributed computing environment. So that's up to today's class. Tomorrow's class we will see the map reducing, and also in this we have seen the only the map reduce example here. In the this coming session we will see what are the map reducing technique and what are the programs we are using for, means what are the methods or what are the definitions we have been used for processing. And also we have been seeing several examples and what are the how are the ways it is using and how these map reduce will be used in several environments. Thank you.